Assalamualaikum dan salam sejahtera kepada semua pelajar. Selamat datang ke channel MaGic ReVision, program ulang kaji secara online bagi pelajar-pelajar matrikulasi khususnya sebagai persediaan untuk menghadapi PSPM 1 yang bakal berlangsung tidak lama lagi. Jadi pada hari ini kita akan mengulang kaji tajuk subjek kita iaitu Mathematic, kod kursus SM015 bersama dengan dua orang pensyarah cemerlang kita, pensyarah matematik yang berasal dari Kolej Matrikulasi Johor. Jadi tajuk yang kita akan kupas untuk ulang kaji kita pada hari ini adalah function and graph, limits and continuity, dan yang terakhir differentiation. Jadi ketiga-tiga tajuk ini akan dikupas oleh dua orang pensyarah cemerlang kita dan kita akan ada sesi soal jawab di pertengahan ulang kaji kita, iaitu selepas tajuk function and graph dan limits and continuity kita akan ada sesi soal jawab. Jadi para pelajar boleh mengemukakan soalan di dalam ruangan chat dan selepas itu kita akan diteruskan dengan tajuk differentiation dan lagi sekali di akhir differentiation pelajar boleh kemukakan lagi soalan. Kita ada sesi soal jawab bersama pensyarah kita. Jadi sebelum kita mula saya perkenalkan dua orang pensyarah cemerlang kita dari Kolej Matrikulasi Johor. Pensyarah cemerlang yang pertama iaitu Madam Lim Hui Cheng dan yang kedua adalah Miss Ng Giok Yan. Jadi tanpa membuang masa, saya menjemput kedua-dua pensyarah cemerlang kita untuk memulakan sesi ulang kaji kita. Dengan segalanya dipersilakan.
Hello everyone.
Selamat datang ke sesi hari ini. Saya Miss Ng Giok Yan ataupun Miss J dari KMJ. Dan juga saya dan juga Puan Lim so
saya adalah Puan Lim dari KMJ. Welcome to our slot. So hopefully you can join this program and after this program you will gain a lot of knowledge and you will start to love math and write maths.
So so what we're going to do right now is we are going to start with a live game. So we found that many students are waiting for it because before we go into revision, we have to identify what is the topic or subtopic that we are still lack of exercise. So let us start from a live game first. So may I share the screen right now? So now let us look at it. So
how many people already?
199. Puan Lim?
Oh, good. So that means that our student is very excited and waiting for the game.
So we look at it because just now we already mentioned about you may write down your name and also your institution. So from here we found there's a student from KML, student from KMS, student from KMJ, from KMJ, KMKT, and also from KMPP.
Good. So that means all the colleges from Malaysia is here, right?
Yeah, that's right.
Actually, so, this is just a game, right?
Yeah, this is just a game.
So
that's a 20 question. 20 question. Then
just
would like to
choose the correct answer.
Yes. Choose the correct answer. It's a multiple choice question,
So we give them. Will this game affect my PB marks or not?
No, this is just a small games. My dear, this is just a small game. Just want to identify. Just want to identify from the topic that we would like to discuss which one or which part is still need exercise. Especially from the multiple choice question is test your understanding and also how you manage your time. So are you able to answer it? Yes, don't need to worry about it. It's not hujan rintis. Don't worry.
Don't worry.
So shall we give them some time for those who just enter? You can enter the code 460895 or you can click the link from the live chat.
Okay.
Okay, so
Wow.
let's say
We
if
have
you
a lot of
already
students.
achieve, a lot of students, eh?
Okay.
Okay, if you achieve 400, then we start. Is it okay?
Yeah, just a competition we can see.
Yeah, we can look at the competition, eh?
Okay, so see just who is prepared already, who is not prepared
Don't
yet.
worry,
It's
I will
okay.
only review. I will only review top 5. Okay, I will only review the top 5. So no need to worry. Is it I'm the bottom? Don't worry about it. Identify
Don't
the
worry.
wrong thing before the final exam is much more important. Okay, so 378. So it's a 400. Then we're
Okay.
going to start, eh?
So we only have 400. Okay. Now it's
Okay,
3.
387. So the others, please get ready. When we achieve the 400, we are going to start. 399, 400. Start the
Okay.
game now. Oh, it's still
Oh,
keep on
start.
coming.
Wow. See, it's coming.
It's keep coming. I cannot click. Oh,
Never.
it's well. Okay.
Okay, click.
Okay. The game
Okay,
is started.
Okay, so you just prepare and
Oh.
try to play.
Oh, too many
Oh.
people want to come in, eh? 5, 4, 3,
4, 3, 2.
1. Traffic jam again? No, eh? So it started, eh?
Hopefully you won't traffic jam like yesterday,
Okay.
right? Okay, it's starting already.
Okay, started. Okay, so far at this
Now,
moment,
KMJ.
wow, KMJ. Okay. Dylan. And then the first one at this moment is a dash. Okay, unknown dash.
Don't know unknown. Okay. The second one is Darren Lau, right?
Dylan Lau.
My MD17. Wow, so excited. Okay, what's mean by the yellow and the green and the red colors?
The red one is mean the incorrect question.
Oh, I see.
The red one is the incorrect question, eh?
Oh.
The green is means the correct question.
Okay.
So even though you're very fast, if you answer it wrongly, you also won't get the higher marks.
Oh. That means I have to write answer correctly, only you will get marks, right?
Yes. Okay,
Wow,
let's say I only show the only top 5, eh?
Top 5.
Oh, there are 487 players, eh? Okay, the fifth one, Muhaimin, KMKJ, at this moment.
Kejutan Kedah. Kejutan Johor, I think.
KMKJ. Okay, and that is accuracy 40% at this moment, eh?
Okay.
The player is still increasing, eh? So it means that our student is ready for the exam as well, eh?
So it's from here we only 40% accuracy. That means most of the students not prepared yet, right?
It means that maybe you still have some careless mistake, or maybe you still have some misconception about the question or the topic that we are going to practice. Okay, we are going to test in the final exam lah. So as we know that there are 6 topic, eh?
7.
Okay, now it's decreasing, become 39%.
I think it's still okay because we still have 1 month to prepare, right?
Yes.
So from here we can make it recognize where is our mistake, which part we not prepare yet. So we still have time.
Okay, so now we look at it, eh? So there are KMS, KMP, KMJ, but the top 5 is not coming out yet, eh? We don't know, eh? Who is the top 5 yet, eh? Okay, at this moment, number 6 is No Atiwa, KMJ. Number 7 is Han, KMS. Number 8 is Pong, KMJ.
KMJ.
Yes. KMM is number 10 at this moment. Maybe some of student is shy to write the institution. So like, okay, Angel. Okay. Okay, so let us look at it. Okay. Okay, the top 5, not yet, eh? So this is still the ranking
Now
for
it's the
the
top
500 players, eh? Okay, at this moment, the first one is Dylan Lau.
That one I think is from KMJ.
Okay. Oh, reconnecting. Click here to refresh. Okay, it must be something wrong with it. Never mind, never mind. We can do it again. Actually, it's still running, right?
Yeah, I think student is still running.
Yeah, the student is still running, eh?
Disconnect.
There's too many people, eh? Okay. Okay, actually it's still running, eh? Don't worry. So the second one now is a KMKT.
KMKT. KMKT is Kelantan.
Okay, so we look at the result. Okay, we give you another 2 minutes because the 20 question is not that difficult. Okay, we give them some time to running the live dashboard game. Okay.
Oh.
Wow, there are 2 welcome. Okay, so let us only show the only top 5. See
Top
how
5.
was it? Okay, so it's much more stable, eh? It's okay. It's not stable. Give them some time. We will make it stable. Okay, at this moment, the first one is Pong. Second one is Danish. Third one is Karia. And the fourth one is Ayuni from KMM. And the fifth one is Hayati from KMJ.
KMJ. So now this is the top 5 lah for.
Yes, this is a top 5 at this moment.
Hong.
Okay, so the red one means that the incorrect question. Okay. So how about the orange one? What is the meaning of the orange one? So later we can take a look, eh? Okay, so shall we give them another 2 minutes? And then we are going to end the game. So see how was the result. Okay, so we count down another 2 minutes. So actually the topic that we were going to discuss, Puan Lim, so for your student, actually, which topic is the most difficult one?
Which topic? Okay.
Yes.
So I think in my class, I think most of my students are weak in chapter 5, functions and graph. They are weak in domain and range. Okay, sometimes they hardly to sketch the graph correctly.
Okay.
Okay, so and they have the problem in the differentiations also. Especially comes to the implicit derivative, parametric differentiation, and is the differentiations of the function. Okay, maybe today we can teach them. Okay, how to tackle all these questions easily. Actually, it's not tough.
Okay.
Okay,
so my student, most of them, they say that they are worried about the differentiation because some of them, there is no basic knowledge from SPM. So they're quite worried about the basic concept in differentiation. This is the most difficult topic for them.
Oh, maybe you still can.
Okay. Yeah, so let us count down the 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so end the game. Okay, so let us take a look. How was it? Okay, congratulations.
Wow.
The one is Karia Hafno. The first one is Pong Ching-in from KMJ. Thank you so much. Okay. So it's mean from the quiz. Okay, so there's a highlight from here. The accuracy is only 21% correctly. So it means that we really need the revision. Okay, the toughest question is question number 7. Okay. Yes, 200 out of 500 player is still unable to get the correct answer. And then the longest question is you take longer time to answer is a question 15. And then the interesting fact is 20 question had an accuracy less than 40%. So it means that we really need the revision. So let us take a look. Okay, what is the percentage with the highest percentage? Okay, so we look at it. So far at this moment, 39% correctly. Okay. I think the question 39% is the highest. The smallest maybe is 11. Let's take a look. What is the question number 7? Question number 7. Which topic? Question number 7. Okay. So do not worry about it. Later we can send the link again to the MaGic channel, Telegram channel. Okay. So question 7 is about, okay, given function fx and gx. Okay. One is a quadratic function. One is a square root function. It's about restricted domain and related to inverse. Okay, Madam Lim. So it means that our students still having problem in identify the condition for the inverse function. So this is a tough question among the student that is playing the game lah. Okay, so this is toughest. Okay, so from here, okay, student, you don't need to worry about it. There are few congratulations. Okay, for the first one, you get 75% correctly. Okay. The second one, you get 65%. And the third one, you get 55%. So we still need more exercise. And the exercise, we have to make it consistent. Okay, so without waste our time, so how about let us start our revision for today's.
Okay, no problem.
Okay, so let us start for our revision. So I pass the time to Puan Lim, then she will start the first section.
Okay, so thank you very much. Okay, so from the games, we can clearly see that, okay, most of the students is still not prepared well. Okay, so this is why today, so we choose 3 difficult topics for you. So we try to explain to you what is the important skill in these 3 topics through the questions with solutions. Okay, so let me share my screen first. Okay, so I'm going to start with the topic functions and graph. Okay, so we are going to tell you, okay, what is the important skill in these topics that you should know, and 2 questions on step-by-step solutions. So students, are you ready to learn? So if you are ready, please type 1 in your live chat. Okay. So I know you are ready. Okay, and please prepare a pen or a paper, so maybe you can copy down all the solutions. Okay, so basically in functions and graph, in this topic, there are few important skills that you have to know. Okay, so for examples, the first one, the main basic thing is that you have to know how to find the domains and range of a functions. Okay, so for your information, so domain, we look at the value of x, right? Okay, the range, we look at the value of y. So this is the basic things that you have to remember. Okay, second thing is that you have to know how to find a composite function, let's say FOG like this. Okay, a composite functions, and you have to find an inner or outer function from a composite functions. And third thing is that you have to know how to find inverse functions. And you must remember that only one-to-one function have inverse. That is why sometimes we have to do some restrictions, domain and range, especially for the quadratic and the absolute functions graph. Just now you play the game. So they ask you, okay, what is the restriction? So I think most of you cannot answer. Okay, so this one I will teach you. I will show you an example. Okay, which the case that we have to do the restriction. Why they need to do the restriction is because you want to make the function one-to-one in order to have a inverse function. Okay, finally is the skill of the graph sketching. Okay, normally during the exam, you have to sketch function and is inverse. And you must remember that the function, the relation between the function and inverse, that they are the refractions on the y equal to x. Okay. Okay, come. Let me show, or we try to answer questions on the function and graph, and I will show you, okay, how we apply, okay, all these basic skill in answering the questions. Okay, so first of all, if you look at these questions, okay, they give you two functions. Okay, one is exponential, the other one is the logarithmic function. Okay, first of all, you look at the first question, this says that I'm going to show that it's one-to-one. Okay, when they ask you to show that one-to-one, automatically you have to think of, okay, the function is have inverse. This is why they ask you to show it is one-to-one function. And second thing, at the B, questions B, they ask you to find the composite. You see, they are going to test the skill of composite functions, and hence they are going to find, they ask you to find the relationship based on the composite function. Later I will tell you what is the relationship. Okay, and thirdly, okay, they are going to test you the graph sketching skill. Okay, and finding the domain and the range. Okay, we look at the first one first. The first one, how to show that is one-to-one, the A first. Okay, basically, if you still remember, we have two methods, right, to prove that a function is one-to-one. Okay, let me start with the algebraic approach. Okay, algebraic approach. Okay, can I write, or how do I write that to make me to get a full mark during the examination? Okay, class, you must always start with let the function f. So, because the function is f, show f, so we must start with f function and f function. Okay, I must start with x1 equal to fx2. Okay, it's very easy, class. You just need to substitute. You see, you substitute your x1 in the function f, then x2 in the function f. Okay, you just substitute, you will get 1 mark. Okay, here you already will get a mark here. Okay, after that, you make the comparison. Okay, you are going to compare until you get this. Okay, if you manage to show, okay, from beginning here until here, okay, so you manage to show that E is x1 and equal to x2, then class, you need to make a conclusion to declare that the function is a one-to-one function. Okay, take notes, you never write yes. Yes, what, right? If you write yes, we won't give you any mark. Okay, you must write a sentence or a simple question, a simple sentence to show your conclusion that f is one-to-one function. Okay, clear? Okay, so until you write until this part, only you will get another mark. Okay, okay, so basically this kind of question only have 2 marks. Okay, so if you don't want to use algebraic approach, since the question didn't mention, okay, it didn't mention which methods that you have to use, okay, you are allowed to use the second method, what we call the horizontal line test, or in other words, you call it as the graphical methods. Okay, class, if you want to do the graphical methods, please make sure that you sketch correct graph. Okay, you must sketch exactly the exponential graph like this, and since the graph have an asymptote, okay, so you have to draw the line of asymptote, and you have to denotes the y-intercept. Okay, how I know that my y-intercept is 0? Okay, class, is very easy. At the y-axis, the value of x equal to 0. So you just substitute f0 equivalent to e power of 4, 0 plus 2. So you get the e power of 0 plus 2. That's why you get 1 plus 2, you get 3. Okay, that's why you get your y-intercept as 3. Okay, after that, you have to draw the horizontal line. Okay, the horizontal line can be anywhere as long as on the graph. Don't write below the graph. So you must draw a horizontal line and label. Okay, labeling this. This is the horizontal line. Okay, so you will notice that this graph cut one point. Okay, you must show that it's cut one point. You draw a point here, and then you must state your conclusion based on what situations. Okay, you declare that the function is one-to-one. So the correct sentence you have to write is that since the line y equal to k intersects the graph f one point only. Okay, this is the keywords that you have to write it. The words that I highlighted. Okay, you have to write it. This is the keywords. Okay, then only you declare your conclusion. So f is a one-to-one function array. Again, I repeat. Okay, if you use the horizontal line test, you must sketch the graph correctly and state the reason why. Okay, you say that is a one-to-one function. Okay, this is why students always, it's mostly didn't like to do the horizontal line test because they face difficulty in doing the graph sketching. So if you do have difficulties in doing the graph sketching correctly, so I advise you use the algebraic approach. Okay. Okay. So secondly, is that they want to do the composite function. I think most of you don't have the problem in composite function. You just substitute your function g into the function as the domain. Firstly, I use the function g as my domain and I substitute into my function f. Then only I start to simplify this. Okay, now I will have the e power of ln. Okay, this one you have to have the skill on solving, simplify it. So I always tell my class, you use the formula of e power star equal to star. So I will say that e long bintang equal to bintang. Okay, now what is your bintang? Now your bintang is x minus 2. Okay, so this one you will be simplify as x minus 2, you see? And this one you omitted, so you will get a x here. Okay, clear? Okay, so the second one is you have to find GOF. Okay, so for GOF here, so you apply the skill on finding the composite function. So you substitute your f, okay, as the domain of G. So you substitute into the function G. Okay, here and here. Okay, 2 minus 2 you omitted. So you will get this. Now you apply the property of log. So you bring down your power. So you will have this. And again, the value of ln E is equivalent to 1. Okay, this is why you will have 1 here and 4 here. I can simplify. I will get my x. Okay, so class, since you get both composite FOG and GOF is equal to X, therefore, the conclusions that the relations between F and G, or the conclusions that I can make is that F is equivalent to G inverse, or G is equivalent to F inverse. Okay, this is the purpose why they ask you to find the composite and they ask you to show. Okay, in other words, is the question ask you to show that F and G are inverse for each other. So you may also use this technique. That's it. You find the composite and you show that both FG or GF equivalent to X. Okay. Okay, hopefully you clear with this concept. Okay, then we going proceed to the graph sketching. Okay, class, just now I said that the F and F inverse always is the reflection, okay, on the line y equal to x. This is why during the final examinations, so make sure that you sketch or you draw the line y equal to x. Okay, clear? Okay, then just now, this one is the exponential function graph of fx, and you must denote your y-intercept here. Okay, so this is the horizontal line because the f is away above 2. So please make sure that you draw a horizontal. Okay, if we have the y equal to 2 has the horizontal asymptote, then you must have a y x equal to 2 as your another means the vertical asymptote because they are the refractions. Okay, then class, if you have the graph, the red colors as the function f, then the green colors, this one, since this one and this one, they are the refraction and they are the inverse for each other. That's why this graph will be refraction. If you touch the graph 3 here, y equal to 3, and definitely you will touch another point in the x-intercept as the 3. Just now I already show you how I get the 3 as the y-intercept. Okay, then finally, they ask you to find the domain and range. Okay, I hope that you still remember. You just choose a graph. Let's say I choose the gray color. Okay, from here, I can easily see that the domain of f, domain here to here, so it's the real number, or you may write it as the real numbers here. Okay, or negative infinity to infinity. So the domain of f definitely is equivalent to the range of f inverse. Okay, then the range, if you look at the range, okay, the y, the function away above 2. This is why you will have it, the function always above 2, and the range is equivalent to the domain of f inverse. So this f inverse is your G. Okay, this one definitely is your G. I hope that you can clear your mind and you can memorize or can use this theorem to find the domain and range. It's the question during the exam, they ask you to find it so easily. You just use this relationship. You can denote your inverse function of domain and range. So, okay, this is basically the skill on inverse function, domain and range. Okay, and the composite function. Okay, we go through another questions that we talk about the restricted domain. Okay, so when we talk about the restricted domains here, okay, so basically it's all about to make it a one-to-one function. Okay, class. Just now we say that a quadratic. Okay, if you look at the quadratic, is this is a graph of quadratic on 2 and 5 here. Okay, at beginning, if I didn't do the restriction, so I will notice that, okay, they cut the graph at 2 points. This one is not one-to-one. Because quadratic normally is not one-to-one function. But if you insist, okay, want to make it as have inverse, so you have to make it a one-to-one function. Okay, what should I do? Normally, I have to do the restriction. I have to cut. Okay, for these questions, they already give you the restriction. Okay, this means that they say that, okay, my graph are going to start from 2. This one is open interval because it says that it's greater than 2, right? Okay, it's open interval. Once I do my restriction, the graph will become one-to-one function. Okay, this is why they make a restriction, the purpose why. Okay, the question start with function and giving you a restriction x greater or equal than 2. Okay, now they want you to determine. Class, they didn't ask you to test. They didn't ask you to test whether it's one-to-one, so you don't need to do that. Okay, you just start to find the inverse function. Okay, to find the inverse function, so again, okay, please take note, you have to apply this theorem. Okay, the composite, just now we show already, the relation between the f and inverse, when you do the composite, you are going to get the x. This is why f of f inverse equivalent to x. Okay, then you just substitute, okay, into your function f, exactly. Okay, you make it equivalent to x because this says that you have the inverse. Okay, so and you solve. Okay, come to here. Normally, because if you want to do, it's simplified quadratic, you have to take a square root. Okay, since it's the quadratic, normally we have a plus and minus here. Okay, how are we going to choose? Just now we say that we only can have one x and one y. Okay, so we cannot have one x and two. We cannot have one y with two value of x. So this is why I have to choose. Okay, so based on the given restriction, so this is the restriction that's given. Okay, ini adalah the restrictions domain. Okay, the domain. Okay, and we use the relations. The domain of f is equivalent to the range of the f inverse. Okay, class, greater than 2. What is mean by greater than 2? This is a positive number. Okay, greater than 2 is means that this is a positive number. This is why for these cases, we only have to choose 1 only. So that is a positive value. Okay, class, again, I repeat, I choose positive only. Why? Because based on the given restricted domain, we only take positive greater than 2, so it's positive. So you are not allowed. If you take both, it's not a one-to-one function. The inverse won't exist. Okay, so then only you rearrange until you get the F inverse equivalent to 2 plus square root of x minus 5. Okay, then finally we go to the graph sketching. Okay, so this graph sketching, I just want to emphasize that, okay, the graph sketching is the reflection. Okay, basically, so just now we said that the quadratic is a graph like this. Okay, definitely the square root graph will be something like the chicken wing. Okay, because there are the refractions. Okay, this is why when I do the graph sketching, class labeling is very important. Okay, I want to take, is the make emphasize on here. Okay, so why I do the empty circle? Okay, class, because the questions mentioned, okay, it's greater than 2, not included 2, not included. That's why please make sure that this is the open, open circle. It's not a dense circle. Okay, you have to convince the is the examiner that it says that this is the open interval. Why is open? Because it's greater than 2. Clear? Okay, and again I repeat, in the final exam, if you want to get full marks, okay, please make sure that you labeling the y equal to x, the function f and the inverse labeling correctly. Okay, and the important value of point, please label. Okay, if you have 2, 5 here, so definitely this point will be the 5, 2, because they are the refraction on the y equal to x. Okay, and make sure that you must label your axis. If you didn't label your axis, normally they are going to deduct a mark. Okay, clear? Okay, I hope through these 2 questions, so you will know that, okay, so what is the basic skill that you have to know? Okay, if you have the difficulty in doing the graph sketching, you can use the Desmos graph to help you for the meanwhile for practicing. Okay, you can go to the Google or the Play Store to search the Desmos graph sketching app. So from now you have to practice. So how to sketch the graph correctly. Okay, so that's all for me in the part of function and graph. I pass the slot to the Miss Eun. She will continue on the limit and continuity. Okay, thank you.
Okay, thank you so much, Puan Ling, about the chapter 5. So actually, based on the quizzes just now, we already mentioned about that there's a restricted domain situation for the function that will be a little bit tough for the student. So I hope that Madeline already explained how to make it. So let us proceed to the next chapter. Okay, so the next chapter, it will be limit and continuity. Okay, it's a limit and continuity. Before we enter the chapter 8, we should have some overview of the chapter. Okay, so this is a draft mind map. Okay, so you can take a look. For the chapter 8, we should understand about how to do evaluation of limits, how to finding the asymptote, and also the question related to continuity. Okay, for the evaluation of limits, there are few cases, and some of the cases we call the indeterminate form, if you still remember it. Okay, so from here, there is some important skill that you have to be careful. Okay, so today's we are going to highlight based on these 5. Okay, so the first one, I already said that, is indeterminate form. After we do the direct substitution, you get the situation 0 over 0. Okay, so the solving approach, it will be using factorization and multiplying the conjugate. Okay, so this is the question that we would like to discuss for the question 3 and 4. Okay, and next, do you understand about what is the infinite limit? Infinite limit, it means that when we are finding x approaches to any constant number to a function, you will obtain positive infinity or negative infinity. So this is called infinite limits. Okay, the limits that we obtain is infinity. Okay, and when it comes to limit at infinity, these 2 parts, okay, most of the students, they get confused with it. limit at infinity. Limit at infinity. So which means that when we finding limit, when x approaches to positive or negative infinity toward a function, no matter the function is a polynomial expression or rational expression, okay, what is the limit values that you obtain? So this is called limit at infinity. So please clear about these two. Okay, so for the limit at infinity, we also will facing indeterminate form. So we are going to discuss the one question about solving indeterminate form. And lastly, all this evaluation of limit, which one is related to the vertical asymptote and which one is related to horizontal asymptote. So this is something that we need to catch up and polish. So if you are ready with it, we start from the question number 3. Okay, so let us look at it. Evaluate the limit of the following function. So what is the first step you have to do is, okay, you can try to key it into the Mr. 570. Okay, so this is on Mr. 570, Okay, so we try to key in the fraction alpha x cubed, okay, minus 8 divided by x squared minus 2x. Okay, let us calculate because the limit given you x approaches to 2. So when we calculate 2 equal, you found that there is a math error. So it means that direct substitution, we are unable to get a constant number. So we have to be careful with it, how to solve the problem. Okay, so from here, obviously, when we substitute the 2 here, okay, we will get that it's a 0 over 0, which is indeterminate. So remember the question 0 over 0, we only have to solve by using factorization problem. Okay, we try to think about if I'm trying to modify the question, limit x approaches to 2, the numerator is a cubic function, but the denominator is just a quadratic function where it's a x squared minus 2. So when I mentioned about x squared minus 2, when we do the direct substitution, you obtain the 0 on top, but the denominator you will obtain is just a constant number 2. So this is a case that 0 over non-zero constant. So it means that the values, we consider it as a 0. Okay, so do not make mistake. Or when you're looking at the rational function, we must do the factorization. No, the first thing you have to do is direct substitution. So bear in mind. Okay, the differences between these two similar questions. Okay, so in order to do the factorization, so it means that we have to think about chapter 6, polynomial. How we do factorization for the polynomial with the degree is 3. Okay, so from here, we are not going to show you one by one. It's supposed that you should understand about from the chapter 6, we can solve by using the long division. Okay, from the long division, you get to know that this polynomial is equals to quotient plus remainder over divisor, isn't it? Right, so from the long division, you are able to do this factorization. Okay, if not, you can ask help from Mr. 570 calculator. Okay, but the calculator only will give you the roots. It cannot assist you to do factorization. So we should use our brain to do the factorization correctly. Okay, so let me show you after we do the factorization. Okay, I believe that for those who come in here, you have done with the revision. Just come here to confirm back any misconception. Okay, so from the cubic, you will find that the factorization, you obtain a linear and also a quadratic. Okay, and the denominator, we also found that the x is a common factor. So after you do the factorization, you will find that there are two like terms on top and bottom. So this is the reason why we need to do factorization. We need to eliminate the linear factor will cause the 0 happen at the denominator. If the 0 does not happen as a 0, if the 0 is not happen at the denominator, it's not the indeterminate form. Okay, therefore after you do the factorization, we can eliminate it and you will form a new expression which is a bottom is a linear and the numerator is a quadratic. So what is the next thing you have to do after you do the factorization? Yeah, back to the basic, which is direct substitution. substitution. So direct substitution, the value is 2. So after you direct substitute, just evaluate and give the answer in the exact value form or any equivalence form. Okay, so do remember this is the indeterminate form. Okay, so let us proceed to another one. It is also indeterminate form, but we are unable to use the factorization as an initial step. Okay, so that is a question number 4. You may jot down the question as well. Okay, question number 4, evaluate the limit. Okay, so now it's a rational function as well. Okay, from this rational function, again, we must do the direct substitution. Okay, so you can use a calculator as well. You obtain that this is 0 over 0. And remember, that is an irrational number, is a square root of x. Okay, it's not included the -3. Okay, so how to do factorization? We can do the factorization for the quadratic. But after you do factorization for this quadratic, we obtain 2 linear. And the 2 linear unable to simplify with square root of x minus 3. Okay, this is a reason why there will be the second method, which is multiplying with the conjugate. So conjugate of surd, which is recalling from the chapter 1. Okay, the conjugate of x based on this situation is on denominator. So it will be multiplied with square root x plus 3. So try to recall back. The conjugate is the connecting terms, the connecting sign between the two terms will be opposite. Okay, they are conjugate pair. Okay, so from here, why I'm highlight the conjugate with the pink box, because of we have to make sure the terms that we multiply must be equivalent to 1. If not, we already changed the values of the question. Okay, you dah jadi penggubah soalan dah So please remember, you must substitute top and bottom with the same terms. Okay, then next what we have to do is, we take a look. The 2 terms that I'm boxed up. So these 2 terms that I'm boxed up is a little bit similarly looks like A minus B multiply with A plus B, where your A is equals to square root of x and your B is just a positive 3. So obviously this is equivalent to A squared minus B squared. So you will obtain a linear function x minus 9. Okay, here actually I have some tips for you. You look at this. The tips is when the limit given x approaches to 9 under the 0 over 0 case, so it means that we must try to finding a linear factor x minus 9, or maybe it's a 9 minus x. Okay, we must forming these two, either one, depends on the question, in order to eliminate the 0 case happen at the bottom. Okay, so clear with it, So the denominator settle. Okay, but the numerator, you know that quadratic and square root do not expand. Be careful with it. Do not expand it. If you expand it, you will make it more complicated. Okay, it will make it more complicated. So what we should do for the next part is solving, simplify the numerator. Okay, so simplify the numerator, it means you're doing the factorization toward the quadratic, and the denominator forming the x minus 9 linear factor, because we are going to simplify with the numerator. And lastly, you will obtain a new expression, which is x plus 1 over square root x plus 3. Okay, square root of x plus 3. That's why I said do not expand it. Once expand, everything become complicated. So lastly, what you have to do, direct substitution. Okay, direct substitution. And do not leave your answer in this, because you need to simplify, because the question is mentions about evaluate the limits. Evaluate the limits. So lastly, you are able to get it as a positive 60. Okay, so recalling back, indeterminate form, we have 2 methods, multiplication of conjugate and also factorization. Okay, so I hope that you can understand about these 2 are very important. Then we only can proceed to the situation infinite limit or limit at infinity from Madeline. Okay, I pass back to the Madeline.
Okay, so now I proceed with the next examples. Okay, share my screen first. Okay, so I'm proceed to question number 5. So I'm going to show you how I'm going to apply the limit at infinity and infinite limit in finding our vertical and horizontal asymptotes. Okay, so basically for your informations, vertical asymptotes. Okay, vertical asymptote is the line which is the straight line. Okay, like this, and the horizontal is the line like this, horizontal line horizontally. Okay, so we have to test by using the concept of limits, okay, to find the vertical asymptote. Okay, so again I repeat, okay, normally for vertical asymptote we will test where fx undefined. Okay, so where fx undefined, in other words, we are going to find your infinite limits. Okay, for the horizontal, okay, we are going to test the behavior of y. Okay, we are going to test the behavior of y when x approaches positive infinity or negative infinity. This is why we are going to find the limit at infinity. Okay, so this is the two basic concepts that we are going to use. Okay, so I will show you the solution step by step. Okay, at beginning, just now I said vertical asymptote will happens or it will occurs when the fx is undefined. Okay, you look at here. This is the denominator, it's 2x plus 0. Okay, whenever you get something, a numbers over 0, okay, you will get a max error. Okay, so once you get your max error, this means the graph is undefined. Okay, this is why we want to test when the denominator, so we look at the denominator is 0. So when what is the value of x will make the denominator 0. Okay, when we solve, you get the negative 3/2. Okay, so we assume that, okay, for beginning, we assume that there is a vertical asymptote at the x equal to -2. Okay, how are we going to apply the limit theorem to prove that the vertical asymptote exist? Okay, so just now I said that we are going to see the infinite limit. Okay, so the infinite limit, since the vertical asymptote is a straight line like this, so we have to test from the right and from the left the value. Okay, so in other words, we have to find the left limit and the right limit. Okay, let's say I begin with the left limit. Okay, take notes. Okay, this is the negative 3/2 from the left. Okay, from the left. So if I substitute into my equations, okay, you just use the calculator to calculate. Okay, class, this is the value less than negative 3/2. Okay, if I substitute value here, okay, I will get the 0 negative. So the above one, we just do the direct substitute. Okay, you will get a 10. So this one, you will get the 0 negative. So we are going to get numbers, positive number divided by 0 negative. We are going to get the negative in infinity. Okay, so we get one of the infinite limits. Okay, and the other one, we test for the -3/2 from the right. Okay, this is the right limit. So again, is the value which is greater than negative 3/2. Okay, my denominator will become 0 positive. Okay, 0 positive means that a value which is going near 0. Okay, again, so if we have the 0, okay, 0 positive is here. It's not exactly 0, but it's greater than 0. And this one is the 0 negative less than negative value. Okay, this is why a positive number 10 divided by 0 positive, we are going to get your positive infinity. Okay, class, you see, you get the infinite limits. Okay, you get your infinite limit. Okay, okay, once you get your infinite limit, then you can start to make the conclusions that the vertical asymptote is. Okay, is x equal to, okay, I want to emphasize here, okay, class, please remember to write x equal to, okay, because this is a line. If you write the vertical asymptote is -3/2, this is a value, a point. Okay, it doesn't mean it doesn't represent a line. So if you want to say that vertical asymptote, please remember to write it as x equal to. Okay, so must remember to write it as the x equal to. Why? Because it is a straight line. It's a line. Okay, this is how I use the concept of infinite limit to test the vertical asymptote exit. Okay, so for the horizontal asymptote, just now I say that we have to apply the limit at infinity. So if limit at infinity, we have two. One is positive infinity, the other one is negative infinity. This is our axis. Okay, so this is the negative infinity and positive infinity. Okay, we start to test. Okay, so since the function involves the third function, so you must be careful. Okay, so if I do the direct substitute, okay, you substitute a very large number, so I will get a infinity over infinity. Okay, this is the cases that the Miss Ng just mentions now. This is the indeterminate form, infinity over infinity. Okay, so when you get the case infinity over infinity, okay, so you have to do the technique of divide both sides of numerator and the denominators by the highest degree of x in denominator. Okay, class, the above one is the numerator, the below one is the denominator. So the denominator, the highest degree of x is x. Okay, so since it involves the third function, so you have to take notes that, okay, when x is greater than 0, kenapa dia greater than 0? Because this is the positive infinity. Okay, so this is the 0 in the axis. Okay, positive infinity is a positive value. Okay, negative infinity is a negative value. Since we say that x approaches positive infinity, that's why when x greater than 0, x equal to the square root of x squared. For example, I say that 10, 100, okay, equivalent to square root of 100 squared. So the value is equivalent. Okay, the value is equivalent. This is why when I divide by x and the square root of x squared. This value and this value are equivalent. Okay, they are the same. We only can divide. Okay, you cannot change the question. You only can add something that you won't change the nature of the question. Okay, so once you do in the third form, then only we start to simplify. Okay, 4x squared over x squared, you get a 4 plus 1 over x squared, 2 plus 3 over x squared. Okay, again, class. Okay, when you have the infinity here, you have 1 over x power of n. That means you want divide by a large number, a very large number. That's why you are going to get approaches 0. That's why everything 1 over x squared or 3 over x, whatever is, so you will get it as 0. So you will get it as 0. That's why you get the third 2 over 2, third 4 over 2, so you'll get it as 1. Okay, this is how I evaluate I positive infinity. Okay, then if you have the cases of negative infinity, okay, so again, you substitute, you also will get infinity over infinity. So this is the case that is less than 0. Okay, less than 0 is the negative value. Okay, when the negative value, that's why x is equivalent to a negative square root of x squared. Why? Okay, for example, class. Just now we say that the negative infinity is the negative value. Let's say I choose a value here. So the value, let's say, is negative 100. So I cannot write it as the negative 100. Okay, you square. Okay, when I square it, okay, I will get a positive. Right? I will get a positive. Okay, so that's why in order to make it equivalent, so I have to put a subtraction here. Okay, I have to put a subtraction here. Only you will get negative 100 equal to the negative 100. They only will be equivalent. Okay, so please take note of this. These questions always come out and students always make a mistake. They always forget, okay, to add on a negative infinity. Okay, they always forget to add on a negative sign here. Okay, so this is a negative infinity. Okay. Okay, then you calculate. So this is the negative infinity. Okay, negative square root of 4 plus 1 over x squared 2 plus 3x squared. Again, this one you are going to get a negative value. Okay, so you substitute. So negative square root of 4 plus 0 over 2 plus 0. So you will get a negative 1. You see, you get a different value for the y horizontal. Okay, asymptote. So therefore, the horizontal asymptote, we have two different lines. One is y equal to x, another one is y equal to minus x. Okay, so this is how we do the vertical and horizontal asymptote. Again, horizontal, we find the limit at infinity, and vertical, we find the infinite limits. Okay. Okay, so another next question is the questions on the continuity. Okay, this is the questions of very famous also in the final exam. Okay, before we proceed, so I just want to recall you back what is the test for the continuity test for the point. Okay, for the fx is continuous at the point. Okay, first, if a function is continuous at the point C, so first thing is that the FC is defined. Okay, you must find the FC defined, or you will say that it is exit. Okay, the second thing is that the limit of fx when x approaches C is exit. One is exit, so the limit when x approaches left limit of fx should be equivalent to the right limit of fx. They are equivalent. Okay, then only the limit of fx when x approaches C exit. And question 3 is that the limit of fx when x approaches C should be equivalent. That means that the function should be fulfilled. These three conditions only you will make the function is continuous at the point. Okay, so we just try to look at the question. So you are given a piecewise functions here. Okay, before we proceed, okay, you must look at the function and determine which function is the left function and which function is the right function. Okay, if you look at this, x is less than 3, definitely this is a 3 negative. Okay, this is equal sign, and this is x greater than 3, so this one is a 3 positive. Okay, so you must clarify first which function is the left limit function and which function is the right limit function. Okay, so we proceed with the first step. So we will have f3. Okay, we say that the first step fc. So f3, now the c is 3, right? So your f3. So you see this one is the equal sign. f3. So you will clearly say that f3 equivalent to minus it. Okay, so this one is exit. Okay, it's a real number, it exit. Okay, second step, we are going to test for the left limit and right limit first. So we start, let's say we start from the left limit. Okay, 3 negative, so make sure that we choose the correct functions. So again, I apply the methods that Miss Ng teach you just now. We use because if you do that substitution, you will get case 0 over 0 indeterminate form. So we can solve it by using the factorization. So again, you may either omit the x minus 3 or the 3 minus x. Okay, that's in other words, you want to omit the 0 over 0. So I try to factorize and I get the same factors to omit. So that's why I will get the limit of 3 plus x negative 3 plus x. Then I start with the direct substitute. So I will get the value is minus 6. This is our left limit. Okay, then we proceed to the right limit. So right limit is 3 positive. This is the function. Okay, so again, if I substitute directly, I will get 0 over 0 again. Okay, so I try to think which factors that I have to factorize. You just check first the value here. You look at the limits. Okay, so this is the x minus 3. Either is x minus 3 or 3 minus x. Okay, so this one you have to factorize. So we try to factorize with the x minus 3. So this one to here, you use the long division to factorize. So this is your quotients. Okay, so you will omit it. Okay, so until you get this and you start to substitute directly, you get the minus 6 here. Okay, so you will notice that Okay, class, you will notice that the left limit and the right limit is the same. They are the same. So since the left limit equal to the right limit equal to -6, therefore, okay, the limit affects from both sides, okay, is equivalent to -6. Okay, you notice that step 1 and step 2 already fulfilled. Now we check for step 3. Okay, step 3 is that we have to check whether your limit, okay, is equivalent. So whether your FC is equivalent to the limit of fx when x approaches c. So you see that, okay, this value, the limit is -6 and the S3 also -6. So that's why I can conclude that the value is the same. Therefore, the third condition is also fulfilled. So fx is continuous at the x equal to 3. Okay, so basically, if you want to answer the questions on the continuity, this is the 3 main key, okay, that you always use. Okay, normally they are going to give you something like this, ask you to test whether it is continuous, or in other way around, they will ask you to find a constant, also based on the continuity test. Okay, so this is all for the, is the few questions on the in the limit and continuity. Okay, so basically it's all about, okay, is the factorizations method. Okay, multiply conjugate method for the indeterminate limits, and we use it to find the infinite limit or limit infinity. Okay, and lastly is the continuity at a point. Okay, so I think we stop here for a while for the Q&A questions. So I pass the stage to the moderator.
Okay, thank you kepada dua pensyarah kita. Jadi sekarang kita ada sesi soal jawab. Bagi pelajar-pelajar boleh kemukakan soalan untuk saya bacakan kepada dua pensyarah kita. Okay, daripada YCYH Chong, if the intermediate form cannot be factorized, should we differentiate it using L'Hospital's rule? So soalan yang pertama.
Okay, so this question, thank you, Chong. So I think maybe you are not from matriculation. Okay, for a matriculation level, yes, that's it. When you found that the indeterminate form, because actually we have 7 indeterminate form, but in a matriculation we only learn about 3. Okay, so for this indeterminate form, it cannot be factorized. Yes, it can using the hospital rules. Okay, no problem, but especially when it's involved trigonometry.
Yeah.
Okay, second question, like lim approach something sin x minus x over cos x.
Okay, I think this is a similar question like just now I already answered, right? When that is involved the trigonometry. So factorization, normally factorization is for polynomial, the expression in a polynomial in a rational form. Okay.
Okay, so question dari Shilling Saw, when I face intermediate.
Okay, so for this question, normally we have the function involves surd, only we will multiply with the conjugate, because only the surd term only will have a conjugate function. Okay, if the is a normal polynomial, normally if we have the indeterminate form, so we are going to use the factorization method. Okay, only you involve the third, then you can go.
Maybe I can give you an example. Okay, for example, the linear factor x minus 4. Okay, it can be factorized, become the square root of x minus 2, square root of x plus 2. So if you are able to do factorization, then you no need to multiply conjugate, but it's only limited to 1, 4, 9, 16, 25. So if unable to factorize it directly, then the conjugate method is a compulsory suitable method for.
Okay, next questions from Teo Wen Yi.
May I ask, when we calculate for the vertical asymptote, it's okay if you get both plus minus infinity or both or just get 1 plus. Okay, so for these cases, it depends on the functions. Some function we only have one-sided infinite limit. Okay, so for this kind of questions, because we don't have the both side for the infinite limit, so you are allowed to only show one. Okay, actually, if you get one of the side have the infinite limit, we only can consider this one. That one is a vertical asymptote. If the function have both, then you have to show both.
Okay, next question. Adibah Radinan.
Apa tu? When we divide by x square, should we put cert if equation have cert?
I think the question may be,
when we divide by x square, should we put cert if equation have normally we are going to put it as square root of x square if the equation or the function have the cert form. If not, we just divide by x. Because you want to merge it together in the cert form, so then the kind of question only we put it as the cert of square cert x square.
Okay, next question from Haris Udin.
Is there any possibility that there will be a question where the function has x power of y, where the y is x power of y,
power more than y bigger than 3, so you have power more than 3, I guess.
Why the I is bigger than 3? Okay, so I think for our syllabus, we only involve one parameter, x only. If x and all in x term, if y all in y term, you won't involve the both parameter.
From Joshua Samzongji.
Okay, I think this one, actually we should recalling back what is the definition of vertical asymptote. Okay, definition for vertical asymptote is as long as we are able to obtain infinite limits, either from left or right side limit, as long as you can obtain the infinite limit, so we consider it as a vertical asymptote. But the first situation is you must try to get that the value of x will make the function undefined. Then we only start to finding the two-sided limit, see whether can achieve the infinite limit or not.
From Jack Heng.
I think we already answered the question.
When the value is same, right?
We already answered the question. It must be obtained infinite limit.
From Rubani Swaran Ruban.
Yes.
If the left hand limit does not, both sides does not exist. Yeah, this is why according to the theorem of existence of limit, the limit does not exist. It must be the same. Madam, can we use cubic formulas for factorization? It's okay. No problem. If you can do it correctly, no problem. Because there is no mark for the step of long divisions. So you can use your own way to do the factorization as long as it's correct.
Okay, we have another 2 more questions.
If the denominator is in the third condition, where we are going to know whether we need to multiply. Okay, class. For these cases, the cases multiplied by conjugate is the case for 0 over 0 only. Okay, and directly divide the highest degree is the indeterminate form infinity over infinity. It will happen in the limit at infinity. Okay, again I repeat, for the cases indeterminate form 0 over 0 only, you need to multiply by conjugate. Okay, or directly divide by the highest power of x. Then what is the case limit at infinity? Okay, so I think this student asked about the case infinity minus infinity, right? Multiply by the conjugate first. That's why you that case that you didn't include.
Maybe I can try to answer back just now. Okay, just now the two situation is rational form. Rational form, indeterminate form, we have two situations. First one, 0 over 0. So which is I'm discussed with you, that will be using factorization and conjugate. Infinity over infinity, only divided by the highest. If you get infinity minus infinity, there will be depends on the question.
Then the one is the another indeterminate form.
Yes. So
don't
get confused with it.
That one, of course, I think you mean is that one. The one is the infinity minus infinity. Yes, you have to multiply the conjugate first, then only you divide by the highest degree. The case is the indeterminate form infinity minus infinity. Okay, that one definitely we start from multiply conjugate and divide by the highest degree. But that one is it will happen in the limit at infinity. Again, I repeat. Okay,
Okay, the last question daripada Ashikin.
then divide the x remain.
This is already differentiation.
This differential question.
We haven't entered the differentiation part.
Oh, when divide.
Yeah.
This one. This one.
The next question.
The next Q&A.
Choose another question for last questions. Okay, from Sandra Chu Xiao Yu.
The horizontal denominator is square root of apa?
Square root power
X cube plus
x power of 3.
X cube. X
And
cube
what is the highest power x to be divided? Is the square root of x power of 3. Because the denominator is the square root x power of 3 plus 3x, right? Alright, so your highest will be square root x power of 3.
I think the question is square root x cubes. It means the overall square root. Because the typing, we are not sure the x cube plus 3x is together under the square root or only the so it means because you are not.
I mean is the square root.
So compare the linear and the power 3 over 2. Which one is highest? The meaning of highest is mean, and again polynomial
over 2
polynomial the power. Yes.
Because 3 over 2 compared with 1, 3 over 2 is the highest.
Okay.
Okay, that's it. Thank you for the question. We will continue another Q&A session after we finish our last topic here, which is differentiation. So without further ado, let's invite our host lecturers to give our last topic.
Okay, so now let us proceed to the chapter is about differentiation. So as we know that in our syllabus, the differentiation, we are involved finding the first derivative and also second derivative. Okay, so what is the important skill that we have to take note is the first one, I called it 4 kings. Okay, the rules of differentiation. Okay, I called it Mr. C, Mr. Power, Mr. Product, and Mr. Quotient. So these are the 4 basic rules that will lead us or bring us to further. Okay, so we were using the few questions where this skill will be, this rule will be implied. Okay, and secondly, in a syllabus for matriculation, we have the exponential, the basic. Okay, how to differentiate exponential. Okay, logarithmic and trigonometry function. And the last 2 is the implicit differentiation toward the implicit function, and also the parametric for the parametric differentiation for parametric function. Okay, so I will going to present the 3 questions. These 3 questions will involve the second order derivative in finding the expression, and also the question involve proving. So if you are ready with it, please take note, ready with your pen and also a piece of paper, and then we do it together. Okay. So now we look at the question number 7. Okay, so we are given that of explicit function. Okay, explicit function y equals to quadratic x squared and exponential function. Okay, and we need to find the second order derivative. So it means that this question is not involved the proving part. Okay, it just straight away finding the second order derivative. And we need to give the answer in the simplest form. Okay, so my dear, actually, today we are here to sharing some tips or maybe how we manage the complicated workings that become much more easier. But it still depends on individual. Okay, we're just sharing the idea. Okay, firstly, the initial idea. Okay, you look at these 2 expressions. Is it they are equivalents? Okay, the first one is the original question with the negative index. Okay, for the exponential e to the power negative 3x. And the other one is we simplify. Okay, we do the cross multiplication to make it become this one, as we know that it's a x squared over e to the power of 3x, right? And then we're doing the cross multiplication. You are able to get the left-hand side is a multiplication between the exponential and y. Okay, so why I would like to show you this too. So we should identify which one you would like to use as the beginning. So if you're having problem with the exponential, especially the power with the constant, with the linear function, coefficient is negative. So maybe you can use the second one. But in this case, I already say that the question is not involved proving. Okay, the question is not involved proving. So for me, I prefer stick back to the question and just applying the product rule. The product rule. Yes, that's right. Okay, so we try to recalling back. What is the product rule? Do you still remember product rule? Okay, product rule is something that there are two functions. Okay, there are two functions. Okay, which is denoted as a u or v. Okay, and the first derivative by using the product rule, it will be uv prime plus vu prime. The prime is represent the du dx and dv dx. Okay, this is something that we recall it from here. Okay, so please start from the first one is your u is equals to quadratic x squared. Your du dx, or we call it u prime. Okay, because certain reference book or maybe your notes or module is using a different notation. Okay, but actually they just equivalent. You get back the linear to x. And next it will be v equals to exponent. This one you have to be careful. Still remember or not what is the basic in doing the differentiation toward the exponential. Okay, so as usual, okay, normally I would try to think about it. For the exponential, that will slogan, which is copy back. Okay, we copy back the question. Okay, multiply with ln base. What is your base? It's a e. And we differentiate the power or differentiate the exponents. Okay, so that is a basic. That's why I said it. We are using the basic as well. Okay, so from here, as we know that ln e is equivalent to 1. This is equivalent to 1. After we differentiate the linear negative 3x, you obtain the constant negative 3. So we have to simplify it, start from the coefficient. So you obtain negative 3e negative 3x. Okay, so you can get the u prime and v prime correctly. Okay, if you don't want to memorize or you have forget about the formula, actually you also can use another way. Okay, you can box up. Okay, so using the arrow to represent the flow. Okay, uv prime plus vu prime. Okay, so from here you will obtain dy dx equals to x squared multiplied with negative 3e negative 3x plus 2x e negative 3x. So if you're just stopping at here, we only finish substitute the terms into the product rule formula. So no matter how, we should simplify it. Okay, so therefore I'm going to erase the screen and show you after you get it. This is applying the product rule. Then we found that the exponent is a common factor. So we factorize out. Okay, to get the expression of dy dx. Why we need to factorize it? Okay, you take a look. If you didn't simplify, you will find that there are two product rule need to apply if you want to continue for the next second derivative. Okay, you need to do the product rule twice. So when we're doing factorization, you only left u function is exponent e negative 3x, and the v function is a quadratic 2x minus 3x squared. So from here, we can continue again applying the product rules. Okay, so let the u as a exponent. Okay, v as a quadratic. Okay, so just now we already have the experience doing the differentiation toward the u. So you can straight away negative 3e negative 3x. And the v prime, it will be equivalent to 2 minus 6x. Okay, so you have to show out the workings that, or you can straight away substitute into the formula. So therefore, the second order derivative will be uv prime. Okay, so this is a uv prime plus vu prime. Okay, so again, every time you have to look back again the question. The question only asking for the second order derivative. So you just do the factorization. Okay, then you found that the remaining terms are 4 terms with from the linear, quadratic, and constant. And what's the meaning of simplest form? So it means we need to group the like terms. Okay, because it's given the instruction simplest form. So you found that these two are like terms. Okay, they are same category. So you have to simplify it and try to write it in terms of quadratic in bracket. So this is what we call it simplest form. Okay, so this is a question number 7 when only involve evaluation. Okay, that is not involve the proving. The proving question will be the question number 9. I will show you another way. Okay, so if you are clear with it, then we can proceed to question number 8. So this question is very interesting. Get ready your pen, open your eye, open your ear, and please open your heart and listen to me, and we are sharing together. Okay, this is question number 8. Okay, so where is the question? Okay, so the question is given you y equals 2. Wow, there is so many brackets over there. So what does it mean? So you are given the explicit function. So it means that the function y is from many layers. So in this situation, actually we are applying the chain rule. Okay, I call it Mr. C lah. Okay, so it means that we have to determine the inner function and the outer function. So from here, obviously, the outer function, for the first outer function is a secant. Okay, so we should think about what is the basic differentiation for the outer function. So we have to think about differentiate secant x, let's say, or differentiate secant x, the basic. Okay, everything based back to basic. We will obtain secant x tangent x. Okay, so we must have the basic. This is the first layer. Okay, second layer, it will be cos. So differentiate cos, we will get negative sine x. Right? This is based on our understanding. Okay, and the third layer, which function it should be? It will be ln. So we have to think about what is the basic scale when we are doing ln function. Okay, so we have to think about it. Let's say I'm giving you the basic d dx ln x. Okay, we're recalling back the basic. So it will be equivalent to 1 over, in bracket, ln base. And we are going to differentiate the function under the ln. So that is the basic. So what we should put in the bracket actually is the function under the ln. It can be x. It can be 2x plus 5 like the question. It can be trigonometry again. It can be negative coefficient with the linear form as well. Okay, so in this situation, you are going to put the x here. And this one, you also have to put the x. So lastly, you will find that is equivalent to 1 over x. Okay, this is a reason why differentiate ln x equal to 1 over x. Or we can conclude that actually when you differentiate a ln fx, okay, is automatic is f prime x over fx. Okay, everything is come from the procedure from here. So that is a basic for the ln. Okay, lastly, what is the inner function? The most inside function is a linear. So it's mean our differentiation, you have to differentiate it layer by layer. Okay, so are you ready with it? Okay, so if you're ready with it, I will show you the solution right now, which is using the basic rules that I'm listing out here. Okay, so let us proceed to the solution. So firstly, this is the question. So you take a look at, I already highlight with the different colors. Okay, so we start from the outer function, secant. So secant function, so all the cos, ln, and linear is under the secant. So when we're doing the first, you will copy back again all the function, except the blue one is a secant function, tangent function. Okay, because just now I say that differential secant is secant x, tangent x. Right? Okay, so applying the chain rule, so we have to differentiate the second. right? The first layer is a secant, second layer is a cos, right? This is a cos, isn't it? So we have to write differentiate cos. Okay, differentiate cos, and everything under the cos we also copy back again. Okay, did you clear with it? Okay, so it means we already settled the first layer. Okay, differentiate the first layer settled. We proceed to the second part is differentiate cos. So based on just now the understanding, you should get the negative sign. Okay, so you get a negative sign. Everything copy back because it's not related to the process of differentiation. Okay, so you copy back, you obtain the negative sign again, or the function copy as well. Okay, do not forget what is the third layer. The third layer, it would be ln. So we have to write differentiate the ln 2x plus 5. Okay, differentiate the ln 2x plus 5. Okay, so before we're doing the differentiation toward the ln, actually we can simplify. Okay, did you notice there is a negative terms here? If you want to prevent the careless mistake, you misunderstanding this is an operation of negative or just a coefficient -1, we may put the negative in front of it. Okay, this is how to prevent the careless mistake. Okay, this negative, we put it in front as a coefficient -1. Okay, and copy back again the function sign as usual and only proceed to doing differentiation toward the ln. So differentiation toward ln, it will become, just now is it calling back is a 1 over, right? 1 over linear, differentiate the linear. Okay, so lastly, the last part, differentiate the linear, which is obtain the constant 2. So differentiate the constant 2, you already get 0. So nothing can be continued anymore, right? So lastly, you need to simplify. And I have a habit, when I would like to simplify something, I will start from the coefficient. And then after that, it will be the rational function. Lastly, only the trigonometry. So I double check here, this is a -1. So this one, after you differentiate, you obtain a positive 2. And this is a rational function with the 1. So it means that the coefficient will become 2 over 2x plus 5. It will be wrong. It should be a negative. Okay, so you can put a negative outside and then the coefficient will become, the terms will become the rational function 2 over 2x plus 5. And the other function, you just copy only. It's unable for you to simplify. Okay, there is no double angle. There is no factor formula that can be applied for the trigonometry. So this is a solution. Okay. So I hope that you can clear with it. Actually, the question looks like complicated, but as long as you have the basic and identify the inner and outer function, everything will become quite simple. Maybe you will say that, okay, together, do it together with Miss Jade. Seems like very simple. I believe that you can do it as well, as long as you are focused and understand all the procedure instead of just copying the solution, right? Okay, so if you have any question, actually you all can throw your question into the live chat, or maybe you can post into the channel as well. Okay, the Telegram as well. Okay, we will try to assist. Okay, so we already settled these two questions. Let us come to the last question by me. Okay, which is involve proving. So are you ready with it? Okay, so let us proceed to the question number 9. This is what I mentioned just now. It's an exponential function with the negative index and also together with the trigonometry. Okay, but the question involved other than finding first derivative and also the second derivative. Okay, finding these two, and then hence we have to show that. Okay, we have to show that. So maybe there are different approach, ada mazhab yang berbeza, So I'm just sharing one of it. Okay, I'm just sharing one of it, just a sharing, Okay, that's why firstly, what I'm doing is please try to make it become the left-hand side is the expression y multiplied with the exponents. Okay, because sometimes when the exponent is a negative, we tend to make careless mistake if we forget to differentiate the power to obtain the -2. Okay, so we try to make it systematic. Okay, so what you have to do now is the y, you're unable to express the y in terms of x clearly, so we can consider it using the implicit differentiation. So I will write it as differentiate implicitly with respect to x. Okay, so the left-hand side, we will applying the product rule. Okay, so the product rule, it will become keep the first term y. Okay, they're recalling back to the basic, and differentiate exponent with the positive 2x, so you obtain the 2ex. So this is a u v prime. Okay, come after this, it will be v. So e to x, you just copy back only and differentiate the y. Why we can obtain the dy dx? We have to bear in mind, we already get used with, when we're doing differentiate x is equivalent to dx over dx. That's why we put it as a 1. But now we are differentiate y with respect to x. Okay, actually the ratio is equivalent to dy over dx. That's why you will appear the dy dx here. Okay, so same goes to this. If you differentiate x squared, we obtain 2x using the general power rule, and you are differentiate the x, you obtain the 1. So when you differentiate the y squared, so same situation. Okay, general power rule, 2y, and we differentiate the function under the power. Therefore, you will obtain 2y dy dx. Okay, so this is the left-hand side. Okay, after you obtain the left-hand side, the right-hand side is just the basic differentiation for the sign. So you obtain the 3 because the inner function is 3x. Okay, differentiate the 3x, you get the 3. Differentiate side, you get a positive cos. Okay, so this one you already obtained. Okay, the question asks you to find the first derivative. So we try to make the left-hand side with the terms dy dx. Okay, so I'm shifting the y2 e to x to the right side. And at the same time, when you're shifting, then you can rearrange it from coefficient and the linear function, then only the exponential. Okay, again, so from here, before the right-hand side, okay, before it, if the right-hand side is not simplified yet, I'm not going to move the exponent e to x to the right side. Okay, what I'm going to do now is, did you notice that the y e to x, exactly like the question, okay, exactly like the question, the y e to x is exactly like sine 3x. Okay, it's equivalent to sine 3x. So we replace it as a sine 3x. So you will find that no more y appear over there. Okay, no more y appear over there. And you can try to move the exponent to x to the right-hand side. So lastly, we get the expression dy dx as the following. Okay, so you take a look, only how many steps? 1, 2, 3, 4. 4 steps, we already can obtain the first derivative. Okay, some more the negative idea, the negative term does not exist there. So it means you won't make careless mistake. It can try to reduce the careless mistake. Okay, I already said that this is just one of the approach. Okay, so if you have no problem with it, okay, so let us proceed to second order derivative. Okay, when it comes to the second order derivative, the similar case. Okay, why I say the similar case? Because the negative index appear again. Okay, if I want to continue with the second order derivative, okay, I would like to change it become this as well. Okay, you change it to become the e to x at the left-hand side. If you are having problem how to make it become a left-hand side, please recalling back. Okay, if you're given e negative 2x, it means it's 1 over. Okay, again, for those who forget about it, e negative 2x is a reciprocal e to x. Okay, that's why you do the cross multiplication. You get the left side is multiplied with the dy dx. Okay, so I'm not going to repeat again because it's just a quotient, sorry, the product rule for the left side. May I just proceed? Differentiate implicitly with respect to x for the left side. That's the product rules. Okay, so you just keep it. Okay, we do it step by step, the left-hand side. Okay, when it's involved higher order derivative and there is appear too many notation, maybe you might get confused with it. I have a suggestion is the v prime and the u prime, you can put it in bracket. Okay, for example, this case, you keep the exponent e to x, differentiate the dy dx. Okay, this is your u, this is your v, right? So when you differentiate dy dx for the second time, for sure we will obtain the second order derivative. Okay, and then plus v u prime. So this one is a u prime. This one is a v prime. So when you want to check back your solution, it's also easier for you. Okay, so the left-hand side settled with the product rule, and the right-hand side is a basic trigonometry. So you can straight away get this. Okay, I hope you're clear with it. We don't need to talk much about the basic. Okay, Negative 9 is come from this 3 multiplied with 3. The negative is come from differential cos, you get the negative. So same goes to the second terms. 2 times with the 3 is a 6 because with the negative, so it's a negative 6. Differential sign is a positive cos. Okay? So I hope you're clear with it, the initial step. Okay, so this is the first line. So you try to guess how many lines we can complete the d squared y dx squared. I hope that you can understand about this. Okay, what you have to do is, similarly, you let the d squared y dx squared as a subject. So it means that this one, we move it to the right-hand side. Okay, we move it to the right-hand side. Okay, so left-hand side only remain the terms with second-order derivative, and the right-hand side will be this. Okay, this one you already move it to the right-hand side, and I will rearrange it again, the exponent form, and then the dy dx I put at the back. Okay, again, what is this? e2x dy dx. What is e2x dy dx? Look back again, the question is equivalent to this as well. Right? So you found that you can replace it, and then the exponential form together with the dy dx will disappear for the right side. Okay, you substitute as this. Okay. Okay, you substitute it here, and you found that you are remaining 4 terms with the trigonometry. So which this is a sine 3x, they have the same angle, 3x. And this is also the negative 2 sine 3x. Something you have to be careful here is we are put a bracket. So we need to multiply in. So when you multiply in, be careful with the sign. So it will be negative, negative, positive. So it means it will become negative 9 plus 4. Okay, you will get negative 9 plus 4. It will be negative 5 sine 3x. And this one is a negative 6. And this one is also negative 6. So you obtain the negative 12 cos 3x. Okay, and lastly, you move the e2x to the right side. And again, I have a habit, when there are 2 with the negative terms, we can doing the factorization, which is factorize out the negative 1. So you will make the expression for the second order derivative function as of following. Okay, so how many lines? 1, 2, 3, 4. So when you are moving the terms, at the same time, you can do simplification, simplify the terms. So it will reduce the workings there and also try to reduce the copying mistake. Okay, especially the terms with the negative. Okay, so finally we get the 2 terms. Lastly, what you need to do? Hence, so we have to using the first derivative and second derivative that we obtain, substitute into the left-hand side. So this is a classic way because the question is say hence. Okay, so we have to substitute it to the left-hand side, the terms that we obtain. So there are 3 terms here. Okay. Okay, straight away substitute it. But because the question is show that, okay, the question is show that, you cannot say that, oh, equals to 0, cannot be. Okay, we have to do it one by one. Okay, the y, you substitute here, the coefficient just the same. Okay, and you found that it's also with the common factor exponent. Okay, so you factorize it. Okay, the question, they show that. Okay, so you have to show the terms one by one, eh? Okay, so when you factorize out, be careful with the negative sign. So now we are factorized out the negative. So this one, positive 4 will become, okay, be careful with it. The positive 4 here, something that you can highlight. Okay, the positive 4 and the 3, it should be positive 12, right? But because you factorize out negative, so automatically it's become a negative 12. So same goes to here as well. That is a 4 and negative 2. It should be positive, negative 8, but because you factorize out the negative, so here is a positive. So I think most of the careless mistake happens when you are solving the plus and minus operation, especially when it's involved the combination of the different functions together. Okay, so lastly, you found that 5, okay, 8, 13. So minus 30 is 0. 12, negative 12. So you found that inside the bracket, after we simplify, is equivalent to 0. Obviously, anything multiplied with 0, we obtain a 0, and exactly the same like what we want. Okay, so this is the proving part, involved exponential and trigonometry together. Okay, guys, so you can try, give it a try. Okay, you can copy the question, you can do it yourself, and then later you can ask in the channel MaGic revision. Okay, how about when I given you this question? Okay, the question didn't ask you to find dy dx and d squared y dx squared. It just mentioned about show the function is equals to 0. So you may give it a try. Okay, so I think that these 3 questions from me. So this is what we call it. This one is involve the 4 kings. Okay, product, chain rule, power rule. The quotient rule will be the following question will be shared by Madeline. Okay, that's all from me. So let us pass back to the Madeline.
Share the screen. Okay, so I proceed to the next questions. Okay, basically this is is the implicit derivative questions because we cannot denote the y in the expression of x term. Okay, so basically if you read the question, okay, so they give you the limits. Okay, the y limit is from 0 to pi. Okay, so this one you have to take note and find the value of y first, and then we proceed with the first derivative. Okay, so first of all, we answer the questions first. So we are going to find the value of y based on the given functions here. Okay, so it says that I'm going to evaluate the y when the x equal to 0. Okay, class. So before you proceed, so please make sure that since they give you the range in the term of 0 and pi, so please change your calculator mode to the radian mode. Okay, to the radian mode before you start to calculate. Okay, so since we have the x equal to 0, so we just substitute into the given functions. Okay, so first of all, if I simplify, so I will get my cos y equal to 0. Okay, for these cases, so we need to apply the trigonometric functions rules. Okay, so it says that y is equal to 0. So you may use the calculator, or because the y0 actually, so you get a special angle. So if you can remember, then you can straightforward answers. If you cannot remember, so you just press your calculator, because y equal to 0, so the value to be in somewhere here, and because on the given range we start from 0 and the value of pi, so it involves the first quadrant and the second quadrant only. So that's why we only answers the only answers that we get in the given range is the pi over 2. So if you change the calculator modes to the radian modes, so you will easily to get this answer. I think students should have no problem on this. Okay, you will have a problem when you find your divided. I think I see the chat, live chat YouTube, quite a number of students keep on asking why have the dy dx. Okay, class, we are going to remain the dy dx whenever you do the implicit derivative, you differentiate y with respect to x. Okay, if you differentiate the same parameter, you won't have the dy dx. Okay, so I repeat. Okay, so when we differentiate y with respect to x, so since the y is the y term, if you want to differentiate in respect to x, we have to apply the change rule. That's why you will have your dy dx remain there. Okay, so we proceed to these questions. Okay, so you please take note. Okay, when we are going to have or remain our dy dx. Okay, again, if we want to find this, to solve this, we have to differentiate implicitly. Okay, again, before we do anything, we check the given functions first. Okay, so the outer function here is cos, right? Okay, the inner function is the 2x plus y. Okay, so still remember just now, it says that whenever we want to differentiate the cos u, okay, u is any function, okay, any function. So you will have what? You differentiate cos, you must do your outer functions first. Only you differentiate the inner function. So this is what we call the change rule. This is why when we differentiate cos, the outer function will get a negative sign u, and followed by differentiate Okay, your u with respect to x. Okay, so again, so this one is the change rule. So you do this first. Outer function, only we do the differential of the inner function. So we apply this to our questions. So we do the implicit derivative. So we do the same. So we differentiate again. I repeat, so we differentiate both sides with respect to x. Okay, so I will meet my cos. So I differentiate cos, I will get a negative sign. Okay, negative sign 2x plus y. Okay, so multiply with the differential of your angle. Okay, class, differential your angle with respect to x. Just now in the chat room, somebody asked. Okay, class, if I have this, I differentiate 2x plus I differentiate y here. Okay, differentiate 2x with respect to x, so I will get 2, definitely no problem. And plus this, I differentiate y with respect to x. Just now, I think somebody asked, why teacher, when I differentiate y, you have x to x. Actually, you do the change rule. Okay, what you do is that you differentiate y with respect to y first, only you multiply dy dx. Okay, only the same parameter here, only we can differentiate. That's why you are going to get 1 multiply with your dy dx. That's why you'll get 1 multiply with dx, so you will get the 2 plus dy dx. Okay, again, for next case, other cases, if you have this, actually what we do is that we differentiate the y square with respect to y first, then multiply with the dy dx. Okay, and then it seems like this one and this one you can omit, so you have the differential of dy square with respect to x. So this, from here I change, so I apply the change rule. I do y with y first, only I have 2y multiply with dy dx. That's why you have the 2y dy. This is why you all keep on asking why I will remain. Okay, actually I remain is because I do the change rule. Okay, I cannot differentiate y with respect to x, so I have to apply the change rule. I do it with respect to y first, then I multiply with your dy dx. I hope that you clear with this. Okay, this is my right hand side. Okay, so, sorry, my left hand side. So for my right hand side, if you look at here, I need to apply, or I have to do my product rule. Okay, so since I will have the u equal to 4x, my u prime will be 4. Okay, so v is the sine y. Okay, v is the sine y. Okay, my v prime. So I have to do the sine, differentiate sine first, then I only differentiate my y. So sine is what? Sine is the, if I differentiate sine, I will get cos y. Then I multiply with the dy dx. I differentiate y with respect to x, so I have a dy dx. Okay, so this is how I get. Okay, I do the product rule, so I will have the u v prime plus the v u prime. This is why I will have my 4x cos y dy dx plus the v sine y multiply with 4. Okay, so if you read the questions carefully, so this question mentions that I'm interested in evaluate the value. Okay, so I'm not interested in simplify the dy dx in the x term or y term. So I'm interested in finding the value. So if you do until here, you are allowed, okay, to substitute all the value. Okay, because the question asking the value of dy dx. So you just simply substitute negative sign. So 0 plus y, so pi over 2 multiply with 2 plus dy dx equivalent. So you substitute 4x, so x is 0. So whole statement here, you are going to get 0 plus the 4 sine y is pi over 2. Okay, value of sine pi over 2 is 1. So that's why you are going to get a minus 1, 2 plus dy dx equivalent to 4. So that's why if you rearrange and simplify, you are going to get the value of dy dx as minus 6. Okay, I hope that you're clear. So this is why you do the implicit derivative. Okay, for you to do easily to remember, okay, and actually if you meet the y, you need to differentiate y to respect to x, you just add on your dy dx. Okay, your add on is because you apply the change rule. Again, I said we apply the change rule. Okay, so this is basically one of the example of implicit derivative that normally will come out during your exam. Okay, I will proceed to the next questions, which is called by the parametric equations. Okay, we are going to do the parametric differentiations when you are given a parametric equations as this. Okay, so if you look at this question, okay, you are given the x as 3t minus 1 over t, y with t plus 3 over t, whereby the t not equal to 0. It's not equal to 0 is because want to make the function y defined. Okay, first of all, they ask you to show that, okay, first derivative equal to this, and hence find your second derivative. And after that, you have to express this. Okay, class, to do this, you have to apply the change rule. Okay, so because you're given the x in the t term, so you are going to do your dy dt first, multiply with the dt dx. So it seems like, okay, if you omit dt over dt, so you are going to get your dy dx. Okay, then to do your second derivative, okay, class, what you need to do is that, you see clearly, I have to differentiate my dy dx, my first derivative, with respect to t first. Okay, then only I multiply with the dt dx. Okay, this question or this theory or this theorem always students make a mistake. They always forget to multiply dt dx. They just know how to find differentiate of this. Okay, then they stop. Okay, so the student always lose mark at this part. So please take notes. Okay. Okay, so if you want to showing the following this one, actually for this case, okay, so I will show you how we do this by using the the long division. And lastly, if you want to deduce this question, you have to apply some algebraic theorem, okay, in inequality. I will show you one by one. Okay, so we proceed to the first one first. So if I want to differentiate this one, I say that I have to find my dx dt and have to find my dy dt. So what I need to do is that, so I have to differentiate x with respect to t. So class, take note, this one is dt, dx dt, because the parameter is t. Okay, okay, class. So it's the same thing. I do the implicit actually. Okay, so if I want to differentiate x to t, actually if I do properly, I have to differentiate x with respect to x. Okay, multiply with the dx dt. Okay, then the x differentiate is 1. That's why I will have a dx dt. This is why you always say that the differentiate x with respect to t, you get dx dt. Okay, so this is how we do this. Okay, so I differentiate 3t, I get 3. Negative 1 over t, I get 1 over t square. Okay, so I do the equalize the denominator. So I equalize the denominators. I have the 3t square plus 1 over t square. Okay, so same things with the another one. Okay, I differentiate with respect to t 1 by 1 here. So my dy dt, I will have 1 minus 3 over t squared. Okay, I hope that you want to differentiate, you should have no problem. You just convert into the index form. Okay, you differentiate is that when you differentiate, you just bring down the power, then power minus 1, so you get a minus 2. Okay, multiply vt dt is 1. That's why you get the negative 3 over t square. Okay, so this is how you do. And again, you equalize the denominator. So step to this step is you equalize. Okay, so after that, you find your first derivative. You just do the change rule. This is a change rule. Okay, so class, please take note that your dx dt is 3t squared plus 1. So therefore, if you want to get your dt dx, so it will be equivalent to t squared over 3t squared plus 1. Okay, so you just substitute and you do the simplifications. So this one and this one is the same term. So you will get this. So this is how we show. Okay, So by using the first derivative. Okay, so to find your second derivative, just now I said that you have to do this first. Okay, differentiate the first derivative with respect to t, then you only start with the multiplication. Okay, class, if we look at this, the first derivative, so this one you have to apply the quotient rule. So this is the u over v. Again, so if your u equal to the t square minus 3, your u prime will be 2t. So if the v equal to t square minus 3, your 3t square, 3t square minus 1, sorry. It's 3t square plus 1. Okay, so your u prime, v prime will be 60. So you substitute into a quotient formula. So you are going to start with v. Okay, v u prime minus u v prime. Okay, so you start from here. Okay, over v square. So you simplify. So the basic algebraic, you expand it and you simplify. So you are going to get equal to 20t over 3t square plus 1 square. Okay, says student always too excited. Okay, they always stop here. So actually you not yet finish, right? Because you not yet do your second step. Okay, your second step is that you have to multiply. So your differential of the first derivative with respect to t, okay, with respect to t, you multiply with the dt dx. This is why you can merge and convert, okay, simplify it as this. Or you may write it as 20 t over 3t square plus 1 cube, also can. Okay, this side also can. So up to you. Okay, so then the following questions is that for the part B, they want you to prove. Prove. Okay, how are you going to prove? Okay, again, I have to do the long division. Okay, this one I want to convert in the term of 1 over 3 minus 10 over 3. Okay, how we do this? Actually, we have to do it with the long division. Okay, we do it is the 3t square plus 1 over 3. So you subtract. Okay, you have to get the same term here. So you subtract, you get the minus 10 over 3. Okay, so this is what your quotient, right? And this is your divisor. And this is your remainder. Okay, so your remainder. So you put the polynomial in the form of polynomial over the divisor equivalent to the quotients plus the remainder over the divisor. So this is why you are going to get this. So your quotient, okay, minus 10 over 3 because your remainder is the negative 10 over 3. So multiply with 3t square plus 1. Okay, if you go through a lot of past year questions, you will notice that a lot of questions asking you to prove in this way. So what the skill you need to apply is that you just do the long division and you use the theory of the polynomial, standard form of polynomial. Okay, so you will get it. Okay. Okay, finally is the proving questions. Okay, this one a bit tough if you don't have the basic C of algebraic. Okay, so since we know that you always have to have the beginning. Okay, so we know that if I divide 1 with some numbers, the 3t square plus 1, so I will always get the value 0, 1. So this is the starting. Okay, why I start this? Because they have a theory, because I want to do something with the same as the dy dx here. Okay, so this one, you will see that this one is something like 1 over 3t square plus 1. I have to start from a very basic algebraic, is that the algebra. Okay, this one number is a way greater than 0 and less than 1. Okay, if I multiply both sides, okay, because I have the 10 over 3. So if I multiply both sides with 10 over 3, okay, I will have this. Okay, so this one is means that I multiply 10 over 3. I multiply 10 over 3. I multiply 10 over 3. Okay, class. you see that you will have a negative here. So if I multiply a negative, so basically I have to change the sign. Okay, because I multiply minus 1. So this one I have to bring here and this one will be here. Okay. Okay, when I multiply minus, you will get a negative here. This one will change the sign. That's why you have to always put the negative value here and positive value here. Okay, so and I add on. Then I add on because I have a 1/3. So I add on 1/3 both sides. Okay, this one, if I simplify, so I will get a minus 3. And this one, if I simplify 0 plus 1/3, I will get 1/3. Okay, class, what is this? Actually, this is your dy dx. Okay, this is why you can prove that your dy dx is greater than minus 3 and less than 1/3. Okay, basically the parametric differentiation is basically this way only. So they are going to always start, they have the same pattern. So they have the same trends that you always have to find your dy dx and dy dt first, find your dt dx. Okay, before you apply this, please make sure that your rules of differentiation, okay, you know all the rules of differentiation, it will help you to do. Okay, then you will apply the change rule to find the first derivative. And thirdly, to find the second derivative, what you need to do is that you differentiate the first derivative with respect to t first, and you multiply your dt dx. So definitely you are going to get your second order derivative for the parametric equations. Okay, I think that's all for my sharing on the implicit derivative and the parametric differentiations. So I pass the screen to the moderator. Maybe there will be a slot of Q&A.
Okay, thank you. So now we have the one Q&A session. So the first question from Nishalini Faria Bahir. Madam.
In limit to
limit for piecewise
function. Graph. Okay, so it depends on the question. So if the question asks you to sketch, then you have to sketch. For the limit, I think seldom will ask you to sketch. Okay, so but the piecewise function is that you normally you get this kind of function. What you need to do is that you have to, you have to denote so what is the left function and which is the right function, right limit function. So if the question asks you to sketch, only you sketch. If you want to sketch this kind of function, actually it's not tough. You just sketch the basic graph first in according to the given range. Then only you combine all the function, all the graph together.
Okay. Next question. From Alia Najah.
Okay. So this one, product rule is mean when two different function or two function that cannot be simplified, they have a relation multiplication. If they are having a relation division, for example, x minus 1 multiplied with 2x plus 3 power of 3. So these two function with the multiplication relation. If I make it become x minus 1 over 2x plus 3 to the power of 3, so this one we are applying the quotient rule. Okay.
Okay, question from Lin Mutuku.
Lin Mutuku?
The same question, right?
I think it's the same question.
Yeah, the same question. Okay, from Shukri Sabri.
How we should find the differentiation or trigo or it given in the exam. Okay, so for previously, the differentiation of the trigo is given in the formula list. So I think if you want to I memorize also can. So what you need to do is that you have to do more practice. If you do a lot of practice, you already no need to refer to the formula list.
Okay, next question from Nurjihan Badawiyah.
Question number 9.
I think this one, just now Madam Lim already explained to you, right? As differentiate y squared. So firstly, there is a power form, right? Y to the power of 2. Okay, so when we're applying the power rule, you bring down the 2. So there is 2y to the power of 1. And applying the chain rule, we are differentiate the y with respect to x. Because it's differentiate with respect to x, that's why it's appear dy dx. You try to think about it. When you differentiate x, with respect to x. So it means you will get dx over dx. Actually, it's dx over dx, but we know it's equivalent to 1, so we didn't write it in terms of derivative form. Okay?
Okay. So another from Jihan Alawiyah.
We
Yes,
need
that's
to
right.
find with the 4. Yeah. And turn cos to the negative sign. Yes. Minus 20. Listen, minus 4 times 5 is sin 5x. So remember to minus 5x and never write the minus sign. Minus sin is the sin. So you never leave the write the figure function without the angle.
Okay, next question from Alpha Q.
May I, if the question is an infinite limit or it is an infinite limit at infinity, and also the question is in the indeterminate form, can we use the L'Hospital rules?
Okay, actually, I think this one, just now we already answered it.
If we
Okay,
cannot factorize.
Okay.
Yeah, if we
Okay,
cannot
so
factorize that, if you cannot, yeah. Can you help me to explain more about change rule and power rule? I'm confused between these two rules. Okay, actually, with power rules, we apply the change rule. Okay, can you share the screen, please? Share
Share
my
the
screen.
we share the screen. Okay.
I show you. Okay, these students, they are very confused about the power rule. Okay, the common power rules. Okay, normally we will bring down the power. Okay, the power subtract with 1, right? And we multiply with the f prime. Okay. So if we consider this question, so we have, if we look at the change rule. Okay, actually, this one, they apply the change rule. Okay, why? Okay, you see, you have two functions here. One, the author is the power, n. Okay, and the inner function is the fx. Okay, so actually, it says that if I apply the power rule. Okay, so you see, I want to differentiate. Okay, normally it says that power rule, I say I want dy du, then my du dx. Okay, du dx. Okay, so now you assume that your u, okay, the y equal to u power of n. Okay, that's why you have the fx power of n. Okay, or you apply, okay, so that's why you differentiate y with respect to u, the dy du. So you have the n u power n minus 1. Okay, so, and another thing is that your u equal to fx. So you differentiate your u dx. So your du is f prime. So I substitute back my u equal to fx. So I have the n fx n minus 1. Okay, if I put inside everything, so I have the dy du multiply with the du dx. So I will have the dy du is this n fx n minus 1 multiply with the s prime. Okay, you see that is a relation. Actually, power rule that apply the change rule. You clear? Power rule come from the change rule. Okay, you no need to confuse. Actually, this one is a formula that we create. Okay, some of the mathematics they create based on the change rule. Everything based on the change rule. Okay, clear?
Okay. So next question. Take another 2 questions from Farah
Okay.
Diana.
This one, Farah, okay, you have to make sure first you are doing differentiate with respect to what? If you differentiate with respect to t, the answer it will be 2e to t. Okay, it's been copy back e to t, ln base, and differentiate the exponent. If you are differentiate with respect to t. If you are differentiate with respect to x, then the variable is different, right? X and t. So you have to make sure you are with respect to what variable. Okay. So in this case, let's say I assume it's differentiate with respect to t. It will be 2e to t. Copy back, ln e, multiply with 2. Okay.
Okay, another question from Eliza Fazwini.
Or horizontal asymptote is it if we obtain the same value of y when we do limit at infinity. For the horizontal asymptote, if you want to exit, make sure that when you do the limit at infinity, you get a number, a constant. You cannot get infinity. So if you get infinity, it means that you don't have the horizontal asymptote. Okay, so for example, you look at the exponential graph. So the exponential graph, if you going to the right positive infinity, you don't have the horizontal asymptote at the positive infinity, but you will have a horizontal asymptote at the negative infinity. Okay, horizontal asymptote may happen one side only.
Okay, our last question from Muhammad Fakhrul Amri.
We need to divide with highest power in either numerator or denominator. If we factorize out the x, is that wrong method? Is that wrong method?
Okay, I think this question, okay, maybe you are confusing. Is it when you found that it's a rational function, you must divide the highest power? Okay, again, if you get a rational function, you only divide the highest power when it is infinity over infinity. Okay, you factorize out the x. Let's say if you try, you still will get another form of indeterminate form. Okay, that's why the only solution for infinity over infinity in our syllabus divide the highest power of x. Okay, I believe that the factorizer one of the x is for the case infinity minus infinity. Okay, maybe you can refer back if the situation is infinity minus infinity in both polynomial. Okay, you can do factorization. Okay.
Okay, so okay.
If you still have any question, actually you all can post a question into the Telegram, because just now I go through is quite many questions, because the time is not allowed us to continue. So you can post a question over there.
Yeah, okay.
Any questions?
Okay, so pada semua pelajar jangan risau, soalan-soalan yang rasa belum terjawab boleh lanjutkan soalan tu dalam grup Telegram kita. So link kita akan masukkan dekat dalam grup chat, dan satu lagi jangan lupa untuk isi borang soal selidik atau maklum balas berkenaan dengan aktiviti kita hari ini, program kita hari ini, feedback form jangan lupa isi, okay, untuk kita nak tahu feedback berkenaan program kita. So jadi saya nak jemput pensyarah kita lah untuk yang lain-lain untuk turut serta bersama-sama kita, okay, di program akhir kita ni. Okay. So, jadi ada sebarang kata, dua kata daripada pensyarah-pensyarah kita yang telah bersama-sama menjayakan program ni selama 3 minggu kita ni. Miss Taka.
Okay. Alright, okay, Assalamualaikum dan selamat malam untuk pelajar-pelajar semua. Terima kasih kepada semua pensyarah-pensyarah yang bagi komitmen yang sangat tinggi, dan untuk pelajar-pelajar terima kasih kerana sudi jadi menonton dan mendapat banyak manfaat daripada program yang telah kita jalankan, dan terima kasih banyak-banyak semua feedback yang pelajar dah bagi, kami dah analisis, dan InsyaAllah kita akan dah jumpa anda balik dalam siri kedua. Jadi nantikan iklan yang akan dikeluarkan tak lama lagi, okey, untuk CD yang kedua. Okey, terima kasih atas sokongan pelajar-pelajar.
Okey, terima kasih kami terima. Dan seterusnya ada yang ingin memberi sepatah dua kata.
Okey, saya mewakili KMJ. Kami nak ucapkan terima kasih kepada semua pelajar yang menyertai program kita untuk 3 minggu berturut ini. So ada sesuatu nak kongsi anda. Okay, the code, okay, has given. You can't connect the dots looking forwards. You can only connect them looking backwards. So you have to try that the dots will somehow connect your future. The reason why we put it here is maybe some of you, ada orang yang dia bagi tahu, saya belajar ni macam mana saya aplikasikan dalam kehidupan harian. Okay, kami sebagai pensyarah akademik, okay, kita bertanggungjawab untuk membentukkan dot kepada anda untuk membina you punya jalan. Tapi anda yang kena usaha bagi hubungkan semua dot ini, kita baru nampak you punya future adalah macam mana. So di sini MaGic ReVision, okay, MaGic ReVision kami hanya untuk menolong anda, membantu anda terutama pada musim COVID-19 ini, semua adalah stay at home, belajar at home. Tapi pensyarah bahagian matrikulasi kami tak pernah lepaskan sebarang peluang untuk menolong dan membimbing pelajar-pelajar kami dalam proses dalam minggu-minggu yang kritikal sekarang ni untuk menghadapi PSPM 1 yang akan dilangsungkan bermula 6 hari bulan Januari. So di sini kami mengharap pelajar-pelajar mencarikan dot di tempat yang betul. Kalau dot itu sudah dekat tempat yang betul, kami akan semua akan dapat satu bentuk dan satu masa depan yang agak cerah. Okey, itu adalah perkongsian dari kami. So terima kasih banyak kepada semua penyertai program kita. Okey, pas kepada moderator.
Okey, terima kasih. Yang sebelum kita ada satu video lah kita nak tunjukkan untuk semua para pelajar yang kita kongsi lah untuk bersama-sama para pelajar untuk kita sama-sama saksikan video kita. Okey, itu dia tadi. Kita ada montage. Okey, itu dia tadi montage kita berkenaan video sepanjang 3 minggu ni lah kita, dalam program kita ni. Kita dah bersama selama 3 minggu daripada subjek kimia, kemudian biologi, fizik dan akhirnya hari ni kita ada matematik lah yang terakhir kita. So, jadi saya harapkan para pelajar jangan berhenti di sinilah, untuk kita akan jumpa untuk siri seterusnya, dan jangan lupa untuk like dan subscribe kita punya channel sebab kita nak dapat untuk pelajar-pelajar jangan ketinggalan lah untuk dapat notification daripada kita seterusnya, dan jangan lupa follow kita dalam Telegram juga, dan jangan lupa untuk nak share video-video kita ni bagi pelajar yang dah terlepas untuk kimia, biologi ataupun fizik, boleh tengok semula video kita dalam channel kita. So don't forget to subscribe lah. So jadi kalau pensyarah lain ada yang nak bercakap sepatah dua kata sebelum kita mengakhirkan kita punya program ni, saya buka peluang.
actually is not tough. Okay, so if you can succeed in mathematics, you will get succeed in physics also. So because if you succeed in chemistry also, because you apply the calculation, and finally you also will succeed in the biology. So mathematics is the base of everything. Okay, so I think all the subjects, for the main subject here, come here is to encourage you to, is to show you the way to study, but we cannot sit for you the exam. So you are the one, okay, who sit for the exam, and you are the one who work for it. We just can show you the way. So if you're not willing to do it, though, we cannot do anything. Okay, I hope that all the students outside the live YouTube there, so you start to prepare 1 month only. So it's PSPM. So if you want to change, you can make a difference. If you don't want to change, you cannot make any difference. Okay, that's all. Thank you very much for your support.
Okay. Madam Chia atau Miss Madam EU boleh dua kata terakhir siri satu kita kalau ada.
Students, so never try, we never know. So just keep your momentum to prepare your final. Never try, so you never know. So try your best. Thank you. Good luck.
Okay, Madam Iyun.
All the best to all the students. You can do it. Okay, just believe in yourself. You can do it.
Okay. So itu saja. Lagi sekali saya ingatkan, jangan lupa isi feedback kita, jangan lupa follow kita dekat Telegram, and then don't forget to subscribe kita punya channel untuk dapatkan lanjutan kita punya program selepas ini. Ada siri kedua akan datang, so please stay tune lah. Okay, so saya tamatkan kita punya program untuk siri pertama kita. Akhirnya alhamdulillah kita berjaya lah selama 3 minggu ni. So thank you to all students yang sabar bersama-sama kita, belajar bersama-sama, dan saya berharapkan segala yang kita usaha ni dapat membantulah para pelajar. So thank you to everyone, thank you, and kita jumpa lagi. Bye.
Bye. Love you all. Bye.